Arjun, thank you very much for inviting me to give this talk to EUREOS. It's a pleasure to come and show you our work focused on eosinophilic gastritis and gastroenteritis with a focus on new insights into diagnosis and treatment. The work today really focuses on the next slide, which I'd like to be able to show. Anyhow, the work focuses on work that we've been conducting through the Consortium of Eosinophilic GI Disease Researchers, which is a national consortium in the U.S. It's supported by the U.S., composed of about 15 sites, whose focus is to improve the lives of individuals with eosinophilic gastrointestinal diseases through innovative research, clinical expertise, and education via collaborations between scientists, healthcare providers, patients, and professional organizations. SIGA involves a number of different working parts. We have something called the Data Monitoring and Coordinating Center that monitors our data. This is a centralized research resource from the NIH that allows us to analyze and maintain the data. We have domestic sites in the US that participate in the research. We have consultants as well, primarily in Switzerland. We have an external advisory board with some distinguished doctors in gastroenterology and allergy and pathology and other fields that give us direction. We very strongly partner with PAGs, which are patient advocacy groups, which are critically involved in the research. And we also work together with patients through the PAGs and also independent of the PAGs, particularly with the clinical studies. And we also partner with professional societies, and that's where our relationship with EUREOS is part of the SIGA operation. And we have dialogue and common interests, and I think this seminar today, this short lecture, may be able to be an impetus for further activities between SIGA and EUREOS. And of course, we work with the NIH, and it's funded through an organization, an old grant called the U54, which is basically a cooperative mechanism, so that the grant isn't just us working together, but we're cooperating with NIH experts to advance this set of rare diseases. The research focuses on a number of different components that are dynamic and moving. We have an observational study under clinical care, and we're following our patients with all forms of EGID. We are focused on disease classification. We're not only looking at the cellular and molecular components, but also the disease definitions. We're working to improve diagnosis and prognosis, and the talk today will primarily focus on that. We also are focusing on positioning EGID as a directive from the NIH so that it's readily available for clinical trials, an area that they focus in on for rare disease research, focusing on clinical trial readiness, developing things like the PROs and molecular panels, which I'll talk about, that allow us to quickly move into clinical trials and hopefully advance the field so these are available for others. And we're also looking at targeted treatments aiming to improve outcomes. So the talk today is focused on eosinophilic gastritis, and it's nice to move down the GI tract from the esophagus. Most of the work does focus on EOE because of its prevalence. You can see here estimated prevalence out of 100,000 individuals. EOE would be about 50 individuals, where EG is about 6.3, and EC is even less than that. The diagnosis of EG, like EOE, is dependent upon endoscopic procurement of biopsies, analysis histologically by the pathologists, and enumeration of eosinophils. There is not a fully agreed upon threshold for diagnosing the disease, but SIGA has agreed to use the 30 eosinophils per high power field and at least 5 high power fields for diagnostic purposes for research investigation into this disease. This is a moving target, and some of the work I'll show you today is helping us provide tools and understandings of the changes that take place at different levels of eosinophils in the stomach. And these numbers are based on the calculated averages as well as the maximum that we've seen, and this is the range that's been reported in some studies, particularly in the stomach. Substantial advancement in EOE has taken place through endoscopic biopsies and analysis of molecular transcript profiles. And we, along with other groups, have defined the EOE diagnostic panel, which is a set of transcriptomes that are abnormally expressed in the esophagus, and allows us to probe very rapidly the molecular and cellular components of the disease. And this has truly advanced the understanding of the disease so that we now have targeted therapy available, which I'll come back to at the end. But what I'd like to focus on today is how we've also begun to use this type of approach in the stomach. We reported a number of years ago the EG transcriptome. And this is a set of hundreds of transcripts that are differentially expressed in the stomach of EG patients compared to EOE. One of the early remarkable findings that we had was that there was only 7% overlap between this transcriptome and EOE and the gastric transcriptome EG patients. There was overlap of some of the cardinal pathways, particularly the type 2 immune reaction with the IL-13 and IL-4 and eosinophil signature genes, as well as mast cells. But we wanted to advance the diagnosis of EG by further probing the EG transcriptome. And this is work that we did through Seeger, where we looked at a number of gastric samples across the Seeger sites. And we identified through RNA sequencing a series of genes that were consistently abnormally expressed in EG compared to controls. And this was independent of age of patient, atopic status, site of where this in the stomach versus the different locations, the antrum of the body, and also independent of which institutional gastroenterologist was biopsying. And we came up with a panel of 48 genes that we were able to narrow down that really allowed us to differentiate EG from the control populations. And we even went further to identify 18 genes, which now referred to as an EGD18 panel, an EG diagnostic panel with 18 genes. And what you can see here are the genes that are either upregulated or downregulated in the disease compared to the control. And then you can see in this diagram over on the right, the PCA plots of the patient's EGDP score. And you can see a complete separation of patients with active EG compared to non-EG, and other controls were showing similar patterns, and we were able to replicate this in independent cohorts as well. So this allowed us to develop a scoring system based on molecular profiles, which we refer to as the EGDP18, which is really a summation of the delta CT values of the most highly dysregulated 18 genes. This scoring system does directly correlate with the peak gastric eosinophil levels. You can see a very strong R. It's an inverse association because the lower the EGDP score, the higher degree of abnormal changes. So you can see a very striking correlation. We can also see that we can follow patients longitudinally, probing them with the molecular profile, and this allows us to differentiate patients with active versus inactive disease. And as I mentioned earlier, there's a very strong correlation and consistency between the gastric body and antrum. So we've used the EGDP score to probe the histological and endoscopic features of the disease. And in this slide, we are looking at various EG histological features that are now being used as part of an EGHSS histological scoring system that our pathology experts have developed, particularly Dr. Collins and her team. And this shows you the various scores of these different parameters besides the eosinophil levels and their relationship to the delta CT value of the EGDP score. And you can see that there were some features of the disease, such as the eosinophils in the muscularis and the lamina propria smooth muscle hyperplasia, that didn't have a very substantial correlation. But then there were others, like the periglandular circumferential collars, that showed a very strong association with the molecular changes, and of course others as well, as indicated on the right what they were. We've also been able to analyze the molecular profile as a function of the endoscopic changes. And these are different parameters that we've been tracking in EG: granularity, nodularity, erythema, friability, folds, and erosion and ulcers. And you can see that, again, similarly, the log 10 FDR corrected p-value does show variations depending upon which feature we're looking at. But the most striking ones was granularity, which is shown in the image on the right, and nodularity, which is the micronodules that are characteristically seen in this disease. And they showed very striking and strong association with molecular patterning. And of course, we know particularly what genes are associated with each of these, and that's been recently reported by an article by Schroeder et al. And I refer you to that for the details of what genes they are. Turning back to the diagnosis, we have also been interested, as a major amount of our focus is on developing less invasive and non-invasive platforms. And in EOE, the search continues. There's certainly less invasive testing that's being developed by a number of means, but there's very little success so far with blood markers in EOE that are clinically relevant. Now in EG, we have some encouraging data. This is looking at both plasma and serum from a series of patients and looking at a series of relevant proteins that we identified from a multiplex assay. And this is focusing on ones that showed some promise of particularly biological functional associations with the disease. And what you can see here is the minus log 10 of the adjusted p-value. So these are some very substantial associations between the eosinophil levels and the diagnosis of the disease, and these particular cytokines that we can measure in the plasma and the serum. And you can see that eotaxin 3 is very strongly associated in the plasma, which is stronger than the serum, but both areas. TSLP is very positive in the serum, and IL-5 is a very nice correlation as well in both the plasma and the serum. Eotaxin 3, similar to the esophagus, is one of the chief genes that's overexpressed in the stomach of patients with EG, probably related to the intense eosinophilia that we see. And you can see in the lower data sets that these have individually pretty nice sensitivities and specificities. And this combined allowed us to develop an EG score, which is a 4-point score. It's based on the plasma. With a serum, we prefer the plasma because it's got a higher yield. And this allows us to score the plasma samples from these patients and determine their degree of correlation and diagnostic potential. And what you can see here is that the blood EG score does in fact predict disease activity. In the plasma on the upper left, you can see the EG score in the plasma differentiates patients from active EG from non-EG. There is some overlap, so it's not a perfect score. And you can see that the serum markers as well differentiate them, as well as the plasma EG score differentiates active from inactive, and then also the serum EG score shows similar trends. We've been able to construct receiver operator curves for these plasma and serum biomarkers. And what you can see here is the individual relationships between individual proteins in the plasma or the serum, and their very good sensitivity and specificity based on the area of the curve. But I want to draw your attention to the combination score between these three markers. And what you can see here is in the red line, an area under the curve that's approaching over 0.9, in this case, very nice plasma EG score using this combined score, which we think shows great potential to monitor and diagnose the disease, but particularly for long-term monitoring of the disease. And this is consistent with data that we had in the past, that the blood eosinophil level was also correlative in EG, more so than we typically see in EOE. So in summary, what I've shown you so far today is that we've been able to use molecular endoscopic, histological, and circulating biomarker-based discovery to develop diagnostic panels for EG involving multi-site studies. The sites involve 185 patients with multiple sites across the US, and we've been able to develop tissue-based profiling based on the 18 significant genes which monitor the disease activity, and they improve diagnostic chance, particularly for ambiguous cases that wasn't shown today, and also do correlate with histology and endoscopy. As scientifically, which hasn't really been carefully gone over today, these do, however, also inform information about the pathogenesis of the disease, which is going to help us with development of therapy. And the blood-based markers are very promising, particularly the eotaxin 3, IL-5, TARC, and TSLP. So I just want to close by talking to you about potential therapy for this disease. And this data is old data that we developed a few decades ago, actually, early work that I had done with Simon Hogan, and he was a postdoc in my lab, where we developed a model for eosinophilic GI disease in mice. And we showed that these mice developed a number of features of eosinophil GI disease, particularly in the stomach. And this is looking at the size of the stomach in these mice that were challenged with the allergen. And you can see these mice developed gastromegaly, and this was shown to be due to eosinophil infiltration and a degree of dysmotility that was occurring in the stomach. And at that time, we didn't have eosinophil knockout mice, but we had was eotaxin knockout mice. And these mice were greatly devoid of eosinophils in the stomach, and you can see that they were protected against the gastromegaly, which we linked to external necrosis taking place that was potentially mediated by the eosinophils. So this was some of the early data that established the potential causal role for eosinophils in this disease pathology. We also have seen, as I mentioned earlier, that there's a correlation between the peak eosinophils in the blood and the tissue. More recently, we have conducted a study looking at eosinophil knockout in humans, and this is where a drug called benralizumab. So these patients take this drug, which mediates antibody-dependent cellular cytotoxicity. We've conducted this study, which is a single-site, double-blind study with 24 patients, and half got placebo and half got drug. The study is closed. We're analyzing the data. The data is still being cleaned, but we have an open label extension, and we can tell you that, very interestingly, that the eosinophils are depleted in nearly all the patients. And some patients, like subject 1, have a complete resolution of the eosinophils and a normalization of the histology, a very dramatic change and a clinical benefit as well. Whereas other subjects, we can see here, have a huge amount of eosinophils. They are depleted by the antibody, but the patients still have active inflammation that's non-eosinophilic, that's ongoing. Now, these are patients that had atopic EG that appeared to be very similar to this patient over here. So what we're seeing is already in this early data is there's going to be heterogeneity in eosinophil gastroenteritis in humans, and I predict that some will be independent of eosinophils in terms of the pathophysiology and even the clinical symptomatology. So I'd like to conclude what I've shown you today is that the EGDP score, which only includes 18 genes, was sufficient to diagnose EG cases. The EG molecular profile also strongly correlates particular endoscopic and histological features, thus providing insight into the pathogenesis of EG. Circulating biomarkers reflect local changes in the stomach, potentially serving as an early non-invasive test. The biomarker profile substantiates the involvement of type 2 immunity, and the therapeutic precision strategies that are currently being pursued include eosinophil depletion with the antibody benralizumab, another antibody that shows great promise based on company open release data called lorentelimab, which is an antibody that also depletes eosinophils by a different mechanism, shows very strong promise in EG in phase 2 study. And we also have anti-type 2 cytokine therapy, which is mainly through anti-13, IL-13 and IL-4 drugs like dupilumab, and also specific antibodies against IL-13, which show great promise as well. So I'd like to close by thanking all the people who contributed, particularly reminding you about CIGA, the Consortium of Eosinophilic GI Disease Researchers. This is supported by 3 different institutes at the NIH. It's part of the Rare Disease Clinical Research Network, and we also have a very strong partnership with various patient advocacy groups. Thank you for your attention. I'll be happy to answer some questions.
Thank you so much, Mark. And perhaps we can now put your camera on for the discussion.
Yeah, let's try that.
We'd all like to see you. Thanks, that's great. I'm waiting for the questions to get in. I personally have, I was surprised that only 7% of the transcriptome between EOE and EG were actually overlapping. Did you expect this, or was it a surprise to you as well?
It was a surprise to us, but when we think about it, the gastric transcriptome itself versus the esophageal transcriptome, there's a dramatic difference in the genes that are normally expressed in the squamous epithelium, the esophagus, versus the columnar and more complex epithelium involving multiple different cell types in the stomach. We actually went back and we looked based on that at eosinophilic allergies outside of the GI tract, atopic dermatitis versus asthma, and we compared atopic dermatitis as well to EOE. And we found more overlap than actually EG, but the overlap was actually mainly about 10 to 20% overlap. So even in classic atopic dermatitis, there's going to be a very modest overlap with asthma, and EoE does more align with atopic derm, but not as much as either. And I think what this is telling us, and it comes back to some of the work that we have done with the genetics of EoE, some of the causes for EoE are related to esophageal-specific genes like helpine 14. And we don't yet know the cause for eosinophilic GI disease outside of the esophagus, at least from a genetic point of view. But I predict that we will find that there are other tissue-specific elements that are interacting with the atopic genes, like the TSLP locus, which is another driving force, but more of an atopic predisposition.
Yes, thanks. Here's another question, and that is so let me see. Oh yeah, the patients in the benralizumab group that responded basically with all inflammation and symptoms compared to the ones that did not respond or just had the eosinophil depletion but no symptom or inflammation reduction. Did these patients differ in any other way in transcriptome or other characteristics?
We are currently looking at that. We have not found any distinguishing features, but it's a high priority area. Okay. It's a high priority subject. We haven't found anything yet to distinguish them.
Yeah. Here's a question from Iku Hirano. He asks you, does the plasma biomarker activity correlate with presence of peripheral eosinophilia?
Yes, it does correlate. There is, we looked at that as well, and there are correlations, particularly with some of the cytokines, but also with the molecular profiling in the stomach. Does correlate with some of the peripheral changes as well.
Okay, and here's a question from Alex Trauman. He asks you if EGDP score correlates with
heavy hitters online today. Hi, Alex and Eco.
He says, if the EGDP score correlates with eosinophils, what does it add in addition?
Well, when you look at eosinophils, as we know, you're looking at one cell type, and you're looking typically at an enumeration of that cell. And it turns out, in the case, for example, in EoE, where we know more about it, that we've been able to define at least three different endotypes, and those endotypes have different clinical features, and we believe different prognostic indications. In the most classic one, which would be interesting, obviously, to you, Alex, is the fibrostenotic phenotype that you've worked so elegantly on. And it turns out in our hands, and be interested in yours as well, that the eosinophil levels are not different between all of these different endotypes. And we find, and we're seeing very similar findings with the type 2 cytokines, the other paper we just published by Dunn et al., that there's a lot of heterogeneity in EoE, and we believe also in EG, although EG is not as advanced, but we're predicting that the eosinophil levels are going to be fairly unrelated to some of the other features. And the molecular profiling is giving us a lot more heterogeneity and understanding of the disease and the variability in the patients, and we believe will ultimately prove to be valuable for different biological treatments that interfere with this targeted pathways that are involved selectively in different patients.
Okay, and here's the final question. In the trial with AK002, there were several patients that were included. They had dyspeptic symptoms and eosinophilia on histology. And I personally must admit that often if a patient has dyspeptic symptoms, we do not take biopsies from the stomach. And some of the patients did not have really pronounced abnormalities on endoscopy. So I assume that there's many patients that have dyspeptic symptoms, which is related to EG actually. And there's a chance they'll respond to therapy, anti-eosinophil treatment. Well, we never expected this. What's your view on that?
Yeah. Who's this question from?
Yeah, it's my own question.
Oh, your own question. I think that that's a very interesting point. And with the this study that you mentioned, the Alico study, that was indeed seen that there were patients that were actually de novo patients that were diagnosed initially with, like you said, dyspeptic symptoms, and they responded to the drug. They did have elevated eosinophils, and that was surprising to me and probably to many people. There would be such a high rate of responsiveness in these patients that weren't previously diagnosed with eosinophilic disease.
I didn't expect that. So I thought these were dyspepsia patients with some non-relevant eosinophilia, and I didn't expect them to respond to the drug. Now, because they respond, yes, I assume that these eosinophils play a role in their symptom generation.
That would be an assumption to make. The cyclic antibody also affects mast cells, so you know it's complicated, but it's very interesting and it's important work, and it's very you know, exciting opportunity for potentially helping patients, but more science is needed.
Yeah, so I assume that if we start to biopsy more, now there's in the future treatment for these patients, we have to biopsy more probably. Do you think?
Right.
Yeah.
Right.
Yeah. Okay, Mark, we're gonna
do a lot of biopsies. You know, to get these diseases diagnosed, you obviously, like you said, have to biopsy. But some of these studies, you know, are very, you might call, aggressive with biopsies. You know, like we're designing one now, and it involves 20 biopsies. And that's what my colleagues, the GI doctors that I work with, routinely do when they're working up these types of patients. So some might consider that to be normal, but others might consider that to be a lot. But it's important to know that we need a lot of biopsies to get to these diagnoses established.
Okay, Mark. I'd like to thank you again for your contribution to this scientific symposium. Thank you so much, and also
we'd like to thank bridge together things related to SIGA and EUREOS. Thank you. Have a nice day, everyone.
Thank you, and also thank you to Amanda Cordell and Salvatore Oliva, and to Laurie, who made this logistically possible. And with this, I'd like to conclude our webinar of today. Thank you.